Hello again, Friends Academy, and welcome to another edition of Wonderful Wednesday. And some of you might be wondering, well, why on earth are we calling this Wonderful Wednesday? How come we didn't do it on another day and call it Terrific Tuesday or Tremendous Thursday or even Fortastic Friday? And no, I couldn't think of one for Monday, so forget it. But why do we choose Wednesday and why are we calling it Wonderful Wednesday? And the reason is because one is actually the most common number, or I should be specific, one is actually the most common numeral. Okay. Now, what do I mean by that? Well, let me explain. The number one occurs in more numbers than any other numeral. Now, first of all, let's talk about the difference between a number and a numeral. Our system is based up of only 10 numerals. The numerals our number system is based in are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 6, 7, 8, and 9. 0 through 9 are the 10 numerals we use to write every number. The number, say, for example, 42 is made up of two numerals. The first numeral is a 4 that we put into tens place, and then a 2 that we put into ones place. So that's the difference. Okay, what I'm telling you is that the numeral 1 occurs in more numbers than any other numeral. And in fact, if we approach infinity, if we approach an infinite number of numbers, it becomes clear that the number 1 occurs in virtually every number. Okay, not every number, but almost every single number. I will show you why in the next few minutes. So in order to do that, let's start simple, and let's just look in groups of 10, 100, 1,000, and so forth. And let's start just looking at the first 10 whole numbers, okay, the one-digit numbers, okay, and they are 0 through 9. Those are all the one-digit numbers, and of those one-digit numbers, the number 1 occurs only once. So the number 1 occurs one time out of 10 numbers, or 10%. I know sixth graders, you're dealing with percents right now, so hopefully this is clear for everybody. But the number 1 occurs 10% of the first 10 numbers. Okay? And in fact, okay, you see that there. So let's move on and look at the first 100 numbers. Now let me specify first of all, when I talk about the first 100 numbers, when I say 0 through 99, that's 100 numbers. 1 through 99 is 99 numbers, and then 0 is 100. So let me clear this, and let's move on. So I've broken up the first 100 numbers, 0 through 99, into groups of 10. And the reason why I've done that, we know in this group here, 0 through 9, we know the number 1 occurs once. And in all these other groups, well, they're basically the same thing as 0 through 9, just with the 2, 3, 4, 5 through 9 in the tens place. So in all these other groups, the number 1 occurs only once. Okay, but in this group here, there's a number 1 in every single one of those numbers. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are 10 numbers here that contain the numeral 1. When I add all these up, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 10. I have 19 numbers that contain the numeral 1 out of 100, or, again, sixth graders, you know this now, 19%. So 1 was in 10% of the one-digit numbers, or the first 10 numbers. If we go to the first 100, the number 1's in the first 19% of those numbers. And we see that explained out here. So let's move on and look at the first 1,000 numbers. Okay, so let me clear my screen. And here's the first 1,000 numbers. Again, now I've got them in groups of 100. And the helpful thing about having them in groups of 100, we know that this group here has 19 ones. All these other groups in white would have the same 19 ones. 201, 221, 231, 241, 251, and then to 210s. So there's 19 in each of these groups. And in this group of 100 numbers, the number 1 occurs 100 times because it's in every one of the numbers. So now you've got 9 groups of 19, and you've got the 100 out of 1,000. Okay, so if I pull up my spotlight, do this calculation, 9 times 19 plus 1,000 plus 100, there's 271. So in the first 1,000 numbers, the numeral 1 occurs 271 times, or 27.1%. Notice it's gone from 10% to 19% to 27.1%. So we could go on indefinitely, but we're not going to. But let's look at the first 10,000 numbers. The numbers 0 through 9,999. Now we know in each of these groups, there's 271 ones. And in this group here, there's 1,000 numbers that contain the number 1. We're not talking about the number ones. We're talking about how many numbers contain the number 1. Okay. So again, we have 9 groups of 271 plus 1,000. And we're going to divide that all by 10,000 because we're talking the first 10,000 numbers. And we'll do, oh, we got it right here. I can just change this. 9 times 271 plus 1,000 divided by 10,000 is 0.3439, which means in the first 10,000 numbers, the number 1 occurs 34.39% of the times. Almost 1/3 of the first 10,000 numbers have a number 1. Okay, so you see it's getting more and more common. Okay, in fact, the first 10,000 numbers have 3,439. So I'm going to write that down, 34.39%. And again, you've seen I've marked it down here, 34.39. So each 10,000, each group of 10,000, we need to remember this as we move on to the first 100,000, is 3,439 numbers. So let's clear the screen and move on. So again, 3,439 in each of these groups. So now we're talking the first 100,000. And this group of numbers here, there's 10,000 numbers. And the number 1 occurs in every single one. Okay. So if we're going to do this out, let's pull up my spotlight again. We have 9 groups of 3,439 plus 10,000, just to show what that's equal to, 40,951. So in the first 100,000 numbers, almost 41,000 of them have a number 1, have a numeral 1. Divide that by 100,000, we get 0.40951, which is approximately, well, not approximately, exactly 40.951%. Okay, now, we could go on and on and on doing this. I could jump now to the first 1 million numbers, then the first 10 million, then the first 100 million. In fact, I've got nowhere to go today. Okay, so I'm staying at home. I've got plenty of time. I could do that. But you know what? I also know I can graph data. I can graph data. I can do what's called a regression to come up with an equation that represents that data. So let's do that instead. So I use a program called Desmos, and I created a graph, which we'll see here. I entered in these numbers, and I'm going to minimize myself here a little bit so I'm not in the way. So at 0, there are no numbers that contain 1. When you're at 10 digits, it's 10% of the numbers. 100 numbers is 19%, 1,000 numbers 27.1%, 10,000 numbers 34.39%, and 100,000 numbers 40.951%. Right there, up, just like right there, right above me. It's backwards, so I'm getting used to this. Okay, so when we plot this on a point, we see it like this. Now it's all bunched up over here because notice the scale on the x-axis. I mean, that's 5,000 right there. So I mean, you're talking 0, 10, 100. Those are really close to 0 on that scale. Then 1,000, then over there's actually that's 10,000. Then over there's 100,000. You can see this is curving upward. Okay. Now there's a process in math called regression. Regression is actually when you can take a set of data and come up with an equation that represents that. Come up with an equation that sort of models that. 8th graders, we did this earlier this year. 7th graders, you'll be doing this next year. Rest of you are going to have to wait a few years. And we'll be doing with lines and maybe some simple curves, maybe not something quite so complex as this. But when we do a regression, we get this 5th degree polynomialist, wow, crazy looking equation, which gives us this sort of crazy looking graph. But notice this graph goes through almost every point, and it's at this point here, it really starts closely modeling the data. Okay? But what's really important is this equation here. And let's make sure we understand what each of these numbers mean. The letter y, or the variable y, represents the percent. And the variable x represents the number of numbers. Whoop. Accidentally changed colors. How about that? Okay, so it represents the number of numbers. So if I could put in a percent for y and calculate this out, it will tell me how many numbers that is. And in fact, I did that. Well, I didn't actually do that. The program did. Okay. And I found out that when you plug in the number 50 for y, which is 50%, it's at 972,287 numbers. That means that just under 1 million numbers, half of all of those numbers contain the numeral 1. Well, then that means the other half has to be made up of the rest of the numbers. Okay? And in fact, if I went out actually to 100 million, at 100 million, it's almost 95%. So the number 1 is clearly the most common number. Okay? And it has to be based on what I've just shown you. So your challenge, should you choose to accept this, and this is not a mandatory assignment, okay, is what is the second most common number and why? So, I mean, there are 9 other numbers to choose from, 0, 2, 3, 4, 5, 6, 7, 8, 9. Can't just guess one. You've got to give a little explanation as to why that number is the second most. I'll give you a hint. It's not 0. Okay? 0 we don't use as a leading digit, so you never get a whole group of numbers beginning with 0, like you get the hundreds and the 1,000s and the 10,000s begin with the number 1. So now I've narrowed it down for you. It's between 2 and 9. Okay. So again, which of the numbers is the second most common and why? If you're one of my students or a teacher who uses Google Classroom, I'm going to encourage you to put your answer in the stream. Okay. I will be posting the solution for my classes Friday at noontime in the stream. You'll see it there. Your other teachers, if you have another teacher, they'll be telling you about it and they'll be sharing with you the solution at some point. If you don't use Google Classroom, maybe your teacher will have you email him or her the solution, or perhaps you'll be able to share the solution some other way. Now, a couple of weeks ago when we had the Simpson challenges, I had 1 million bonus points. Again, they're completely worthless and imaginary bonus points. But I had 1 million of those completely worthless and imaginary bonus points at stake. Nobody got it. Some people got 3 of the correct answers, but the third question was 2 parts, which was how many shirts did I wear and which color was the one that I wore backwards. I didn't wear any of the shirts backwards, so nobody got it. So those 1 million worthless imaginary bonus points have been earning interest. It's been compounded continuously, something we could possibly talk about another Wonderful Wednesday. And there are now 1,299,827 imaginary bonus points available if you're able to solve this problem, which is also an interesting number because it's prime. So if more than one of you get the solution, I don't know how I'm going to divide this up because that's a prime number. It's only divisible by 1 in itself. Okay, well, that's all. So again, hopefully you enjoyed this video. Think about it, and if you come up with a solution, do feel free to share it. Maybe I'll even share some of the best solutions in another video. Okay, that's all. Have a good day.